Chain rule is one of the most important rules when we have to find derivatives. When to use it? Well, let's consider a simple case. That is pretty straightforward. All we have to do is bring 15 to the front and decrease the power. And we have 15 times x raised 14. But if I change the question, x squared plus 1 raised 15, then, well, should we FOIL to find the derivative? That is, write x squared plus raised 15 as x squared plus 1, x squared plus 1, times x squared plus 1, x squared plus 1, 15 times. Well, if you have a lot of time, go for it. So the answer is absolutely no. Should we use the product rule? $14 times. The answer is no. It's going to take a long time. So what do we have to understand here? This goes back to composition of functions. Suppose f of x is simply x raised 15 and g of x is x squared plus 1. Then f composed g of x would simply mean f of g of x, and every x in f would get replaced by x squared plus 1. So here we have x, so the x squared plus 1 would replace x in x raised 15. So we would end up having x squared plus 1 raised 15. So that gives us an idea as to when to use the chain rule. Chain rule is used when a function is within a function, that is, composition of functions. If you look at my example above, x squared plus 1 is inside x raised 15 to give x squared plus 1 raised 15. How do we go about finding the derivative? It's pretty straightforward. So we are going to treat x squared plus 1 as x. So what is the derivative? We have 15, x squared plus 1 raised 15 minus 1. But whatever we have inside is not just x, rather it is a function of x. So we multiply by its derivative, so we have 2x. So 15 times x squared plus 1 raised 14 multiplied by 2x. The answer is 30x times x squared plus 1 raised 14. That's it. You see how simple that is? So instead of doing, product rule 14 times or foiling it 15 times, it is unnecessary. That is the answer. And that is the idea behind chain rule. We call it chain rule because it sort of goes in a chain, and if you have to take the derivative one more time, you would kind of recursively go as a chain, and hence the name chain rule. So here we have f of x is equal to x cubed times sine 4x. U is x cubed. V is sine 4x. U prime is easy, simply 3x squared. V prime, on the other hand, is not simply cosine 4x. The reason being, if this were to be x, the answer would simply be cosine x. But we have cosine 4x, sine 4x, so the derivative is cosine 4x multiplied by the derivative of the function that is inside, so we would have 4. So v prime is actually 4 times cosine 4x. Now we could go about using the product rule, which is uv prime plus vu prime. So we have x cubed times 4 cosine 4x plus v is sine 4x times u prime is 3x squared. We have x squared in common, so if we pull that out, we have x times 4, which is 4x cosine 4x, plus 3 times sine 4x. So in the next problem, we have two algebraic functions, one raised to the power of 3, other raised to the power of 4. And if you FOIL this, it is going to take forever to find the derivative. So what we have to do is use chain rule. U is x squared plus 1 raised 3. I'm going to treat whatever that is inside as x. So the derivative of x cubed is simply 3x squared plus 1 raised 2. But keep in mind, in the inside, we don't have x, we rather have x squared plus 1. So we multiply by the derivative of 2x squared plus 1, which is 2x. V, similarly, is x squared minus 1 raised 4. V prime, if I treat x squared minus 1 as simply x, I have 4 times x squared minus 1 raised 3, but multiply by the derivative of the function inside, I get 2x. So now I could use product rule. F prime of x is simply u v prime plus v u prime. U is x squared plus 1 raised 3. V prime is 4 times 2x times x squared minus 1 raised 3. V is x squared minus 1 raised 4 multiplied by 3 times 2x times x squared plus 1 squared. I have a 2x in common. I have x squared plus 1 squared in common between those two terms. And I have x squared minus 1 cubed in common between those two terms. So if I pull 2x out, I'm left with 4 times x squared plus 1 cubed times x squared minus 1 cubed plus x squared minus 1 raised 4 times 3 times x squared plus 1 squared. If I pull x squared plus 1 squared out, I have 4 x squared plus 1 x squared minus 1 cubed plus 3 times x squared minus 1 raised 4. Finally, if I pulled x squared minus 1 cubed out from those two terms, I'll have 2x times x squared plus 1 squared times x squared minus 1 cubed multiplied by 4 times x squared plus 1 plus 3 times x squared minus 1. I can simplify the term inside. Four x squared plus 4 plus 3x squared minus 3, which would give me 2x times x squared plus 1 squared times x squared minus 1 squared, 7x squared plus 4 minus 3 is 1. So there are a couple of ways to approach this problem. What I'm going to do is I'm going to treat u as e raised t squared plus 1 and v as cosine t. U prime, that t squared plus 1 is a function within e raised t. So what I'm going to do is write it as e raised t squared plus 1 multiplied by the derivative of t squared plus 1, which is 2t. V prime is derivative of cosine of t, which is negative sine t. Now we could use, I don't want to call it as u, cause confusion. I'll call it as p and p prime. That is p, that is v. So u prime of t would equal to p v prime plus v p prime. So p is e raised t squared plus 1. V prime is negative sine t. V is cosine t. P prime is e raised t squared plus 1 times 2t. We have e raised t squared plus 1 in common. So if I pull that out, I have negative sine t plus 2t times cosine t. I don't like to start an expression with a negative sign, so I'm just going to write it as e raised t squared plus 1 times 2t cosine t minus sine t. So here is an interesting problem. By the looks of it, you may say, oh, it looks weird. Oh, I'm missing a parenthesis here, so I'm going to put parentheses. So if you look at it, g of t, I could say it is s cubed, and f of s is sine t minus cosine 2t. If I compose, that would simply go in there. So a function is within a function. So I'm going to treat whatever that is inside as x. So g prime of t would simply be sine t minus cosine 2t raised 2 multiplied by the derivative of whatever that is inside. So cosine t minus, over here it's not just t, rather it is 2t. So we're going to treat it as t. So cosine of 2t would be sine 2t, but we multiply it by 2, or negative sine 2t. So it kind of goes in a recursive manner. So we have, hence the name chain rule. So 3 times sine t minus cosine 2t squared multiplied by cosine t plus 2 sine 2t. So here, t plus 1 over t minus 1 is inside t cubed. So the function that is inside is that. So to find the derivative, we are going to treat whatever that is inside as t. So the derivative would be 3 times t plus 1 over t minus 1 raised to multiplied by the derivative of t plus 1 over t minus 1. That is the function that is in which is inside. So let me do d over dt of t plus 1 over t minus 1 separately. We need to use quotient rule. Numerator is u, denominator is v. U prime would simply be 1 and v prime would be 1. So the formula here is v u prime minus u v prime divided by v squared. So that would mean we have t minus 1 times 1 minus t plus 1 times 1 divided by t minus 1 squared. So that would give us t minus 1 minus t minus 1 divided by t minus 1 squared. The t's would go away and we'll have negative 2 divided by t minus 1 squared. Mind you, that is not the answer. We have to take this answer and plug it in here. So the answer to the original derivative is 3 times t plus 1 over t minus 1 squared multiplied by negative 2 over t minus 1 squared. So the answer is negative 6 t plus 1 squared divided by t minus 1 times t minus 1 squared is t minus 1 cubed. That should be x. So from the get-go, we have to use quotient rule, and we need to find the second derivative. So let's start with the first derivative. So u is e raised x plus e raised negative 2x. V is e raised negative x plus e raised positive 2x. U prime is e raised x. We don't simply have x, rather we have negative 2x, so we've got to use chain rule. E raised negative 2x multiplied by the derivative of negative 2x, which is negative 2. So we have e raised x minus 2 times e raised negative 2x. We know the derivative of e raised negative x is negative e raised negative x. Again, we simply do not have x, rather we have 2x. So we multiply by the derivative of 2x. And that gives us negative e raised negative x plus 2 e raised 2x. So g prime of x is simply v u prime minus u v prime divided by v squared. V is e raised negative x plus e raised 2x. U prime is e raised positive x minus 2 e raised negative 2x. Minus u is e raised x plus e raised negative 2x. V prime is negative e raised negative x plus 2 e raised 2x. Divided by v squared, which is e raised negative x plus e raised positive 2x squared. Always simplify, especially if we have to find the second derivative. So I'm going to FOIL e raised negative x times e raised positive x plus e raised negative x times e raised negative 2x plus e raised 2x times e raised x minus 2 e raised 2x times e raised negative 2x minus e raised x times negative e raised x, which should be negative e raised x times e raised negative x, plus 2 e raised x e raised 2x, minus e raised negative 2x e raised negative x. One more term, plus 2 e raised negative 2x e raised 2x. Divided by e raised negative x plus e raised 2x squared. The first term would reduce to 1. The second term would reduce to e raised negative 3x. The third term would reduce to e raised positive 3x. The fourth term would reduce to negative 2. In the second parentheses, that would reduce to 1. We have a negative 1 in the front, so positive 1. 2 e raised 3x, we have a negative in the front, so negative 2 e raised 3x. E raised negative 3x, and we have a negative in the front, so positive e raised 3x. I feel like I made a mistake here. That term has to be negative 2 everything is okay. So e raised negative 3x, and those two terms, e raised negative 2x times e raised 2x, would become 2, and we have a negative in the front, so we have negative 2 divided by e raised negative x plus e raised 2x squared. If we combine the terms, those two would go away, or those three, and we have e raised negative 3x and e raised negative 3x, which is 2 times e raised negative 3x, e raised positive 3x and negative 2 e raised positive 3x, and negative 2 divided by e raised negative x plus e raised 2x squared. we have a negative 2 in common, or a 2 in common. So 2 e raised negative 3x minus e raised positive 3x minus 1 divided by e raised negative x plus e raised 2x squared. So that's just the first derivative. Now for the second derivative, we're going to treat that as u and that as v. I have to go back and do this. I seriously feel that I made a mistake here. So let's just redo this. So the first two terms, we have e raised negative x times e raised positive x minus 2 e raised negative x, e raised negative 2x plus e raised 2x times e raised x minus 2 e raised negative 2x times e raised positive 2x. Then next, I'm distributing the negative and multiplying the terms. So I have e raised x, e raised negative x, minus 2 e raised x, e raised 2x, plus e raised negative 2x, e raised negative x, minus 2 e raised negative 2x, e raised 2x, divided by e raised negative x plus e raised 2x squared. The first term would reduce to 1 minus 2 e raised negative 3x plus e raised positive 3x minus 2 plus 1 minus 2 e raised 3x plus e raised minus 3x and minus 2 divided by e raised minus x plus e raised 2x squared. Those terms would get cancelled, and let's see if we could combine terms. So if I combine that term with that term, I would get negative e raised negative 3x if I combine that term and that term, I would get negative e raised positive 3x, and I'd have minus 2 divided by e raised negative x plus e raised 2x squared. I could pull a negative out and leave it as is, negative 1 e raised negative 3x plus e raised 3x minus 2 divided by e raised negative x plus e raised 2x squared. So that's just the first derivative. To find the second derivative, I'm going to treat that as u. I'm going to treat that as v. So u would equal to e raised negative 3x plus e raised 3x minus 2. V would equal to e raised negative 2x plus e raised 2x squared. U prime, those are not just x's, rather there is a 3, so we have to use chain rule. E raised negative 3x multiplied by the derivative of negative 3x, which is negative 3, plus e raised 3x multiplied by the derivative of 3x, we get positive 3. We can use chain rule here again, because that's the function the inside. So we have e raised minus x plus e raised 2x. Raised to minus 1. The derivative of the inside is negative e raised negative x plus 2 e raised 2x. So the second derivative of x would be v u prime minus u v prime divided by v squared. V is 2 e raised negative x plus e raised 2x. U prime is 3 times e raised 3x minus e raised minus 3x minus u e raised negative 3x plus e raised 3x minus 2 multiplied by v prime 2 e raised negative x plus e raised 2x times e raised negative e raised negative x plus 2 e raised 2x divided by v squared, which is e raised minus x plus e raised 2x squared, and we are raising it to the power of 2 again. In the numerator we have, don't forget the negative in the front, we left that negative, so we have to put that negative here. So we will just throw that in here. In the numerator, we have that term and that term in common. So if we pull that out, we have negative 2 e raised negative x plus e raised 2x. And we are left with 3 e raised 3x minus e raised negative 3x minus e raised negative 3x plus e raised 3x minus 2 times negative e raised x plus 2 e raised 2x divided by e raised negative x plus e raised 2x raised to the power of 4. Those two would get cancelled, and the answer is negative 2. 3 times e raised 3x minus e raised minus 3x minus e raised minus 3x plus e raised 3x minus 2 times minus e raised x plus 2 e raised 2x divided by e raised negative x plus e raised 2x raised 3. This is quite a complicated problem. Requires a lot of patience. As you saw, I made a mistake earlier, so be careful. So here is a function where we have t squared plus t plus 1 on the inside. We are going to treat that as x, so the derivative, or t, so the derivative of sine t squared plus t plus 1 is cosine t squared plus t plus 1, but since we have a function inside, we're going to multiply by its derivative, so we have 2t plus 1. So the answer is 2t plus 1 times cosine t squared plus t plus 1. So we have to find the second derivative of this function. That is u and that is v. So u is sine 4x. V is 1 plus sine 4x. U prime is cosine 4x multiplied by the derivative of 4x, which is 4. V prime, the derivative of 1 is 0. And that would be V prime. I'm using chain rule. So y prime is v u prime minus u v prime divided by v squared. V is 1 plus sine 4x. U prime is 4 cosine 4x minus u is sine 4x, and v prime is 4 cosine 4x divided by the denominator, which is 1 plus sine 4x squared. Always simplify, so we have 4 cosine 4x plus 4 sine 4x cosine 4x minus 4 sine 4x cosine 4x divided by 1 plus sine 4x squared. Those two terms would go away and we would simply have 4 cosine 4x divided by 1 plus sine 4x squared. That's the first derivative. To find the second derivative, I am going to treat that as u and that as v. So u would equal to 4 cosine 4x v is 1 plus sine 4x squared. U prime is 4. Derivative of cosine 4x is negative sine 4x. Use chain rule. The derivative of 4x is 4. So we get negative 16 sine 4x. V prime, the function here, 1 plus sine 4x is in the inside. So we would have multiplied by the derivative of inside. Derivative of 1 is 0. Derivative of sine 4x is cosine 4x multiplied by the derivative of 4x, which is 4. And you can see the chain moving along. So you have 8, 1 plus sine 4x multiplied by cosine 4x. So y double prime is v u prime minus u v prime divided by v squared. So 1 plus sine 4x squared multiplied by negative 16 sine 4x minus u is 4 cosine 4x multiplied by v prime, which is 8 cosine 4x multiplied by 1 plus sine 4x. And the entire thing is divided by v squared, which is 1 plus sine 4x squared, and we have to square it again. In the numerator, we have 1 plus sine 4x in common. So if we pull that out, we have negative 16 sine 4x multiplied by 1 plus sine 4x minus 32 cosine squared 4x divided by 1 plus sine 4x squared raised to the power of 2. We have a power of 4. So those two would get cancelled. We have negative 16 sine 4x, negative 16 sine squared 4x. I'm just going to split the negative 32 cosine squared 4x as negative 16 cosine squared 4x minus negative 16 cosine squared 4x. It's just, a matter of convenience. Divided by 1 plus sine 4x cubed. And what did I mean by matter of convenience? I'm going to pull negative 16 out. I have sine 4x plus sine squared 4x plus cosine squared 4x plus cosine squared 4x divided by 1 plus sine 4x cubed. Here is the matter of convenience, the trigonometric identity. Since we have sine squared 4x plus cosine squared 4x, that would reduce to 1. So we will have negative 16 multiplied by sine 4x plus cosine squared 4x plus 1 divided by 1 plus sine 4x raised 3 equals y double prime.